Hello. In this video we're going to see how we should solve this integral, that is x to the 7 minus 1 over ln x, with the Feynman's method of integration again. This is a very good method of integration. So it would be good if we didn't have this ln x in the denominator and we could only use the power rule for this one, but that ain't the case. So what I'm going to do, I'm going to define a f of t to be the integral from 0 to 1 of x to the t minus 1 over ln x dx, and if I find the f of 7 from 0 to 1, x to the 7 minus 1 over ln x dx, I'm going to find my integral. So my goal is f of 7. Oops. So I'm going to differentiate both sides of this integral now. Partial t, because the derivative moves inside the integral, it's going to become a partial derivative. X to the t minus 1 over ln x dx. So now, if I differentiate this partially, it's going to be x to the t ln x, because d dx of x to the t is x to the t ln x. We're differentiating a power function, an exponential function, divided by ln x. The negative 1 is also a constant, which is the derivative of a constant is 0. So what I can do right now is I can cancel out these two lns, natural logs, and I'm left with the integral from 0 to 1 x to the t dx, which is very easy to solve, just a reverse power rule. It's going to be x to the t plus 1 over t plus 1, the integral from 0 to 1. Now this is going to be 1 to the t plus 1 over t plus 1 minus 0 to the t plus 1 over t plus 1. The 0 to any power is 0, and 1 to any power is 1 here, so it's going to be 1 over t plus 1, because any number 1 to the power of x is just 1. So my f prime of t is 1 over t plus 1, and now if I integrate both sides of this equation with respect to t, 1 over t plus 1 dt, I'm going to get f of t to be ln of 1 plus t plus c, some constant of integration. Now remember that my f of t was x to the t minus 1 over ln x dx, which is now equal to ln of 1 plus t plus c, some constant of integration. And if I take the limit as both sides as t approaches 0, it's going to be ln of 1 plus c, 0 to 1, x to the 0 is 1 minus 1 over ln x dx. It's going to be 0. It's going to also be 0, thus c equals 0. Thus the integral from 0 to 1 of x to the t minus 1 over ln x dx, it has a general form of ln of 1 plus t. So if I am looking for any integral that is in this form, I can find it by having this power and adding 1 and taking its natural log. For example, in this case, the integral from 0 to 1 of x to the 7 minus 1 over ln x dx is ln of 8. Or if it was 0 to 1 of x to the x squared minus 1 over ln x dx, it was ln 3. So this is how we can solve an integral that is looking scary with Feynman's method of integration. So I hope you enjoyed this video. Please like and subscribe, and I'm gonna read all of your comments, and I will see you next video.